Good morning, trig fans. How are we doing on this bright, sunny, and it is Wednesday morning. I know we start losing track of what days are what days, but it is Wednesday morning. It's sunny outside, but don't let the sun fool you, okay? It's still a little chilly outside. It's supposed to be like that the rest of the week. I hope all is going well. We're back to getting some lessons here. Once again, if you still have some material to turn in, please turn it in. And we're going to continue on through our trig ideas. I hope everybody's safe in your household. I hope everybody's staying ill-free. Hopefully you're keeping your social distancing out there. Once again, I miss you guys. I wish we were back here first period teaching. I know you probably don't, but I do. I wish we were back here first period teaching and learning about trig identities. But we're not there, so this is our reality that we have. But the next topic that we're going to cover is we're going to cover the idea of trig identities. Now, lucky for you, you won't have to prove trig identities. Okay, we're going to go through some basic ideas, some basic properties of trig identities, but you will not have to prove a trig identity. You are lucky. Okay, it is your lucky day. You don't have to do trig identities. We'll get it next year in pre-calc. We'll make sure we spend a little bit extra time in pre-calc next year where we can do a few trig identities. So we're going to go over some basic ideas today. When we're done with these basic ideas, you can take the notes. There is a little exit ticket or exit little exam that you can look at your notes, be able to go through your notes to be able to answer those questions, and that's how I will evaluate you. Once we get into the next section, the next couple days, I'll have a few more mathematical problems that we'll be able to deal with, as we're going to use trig identities, but we're going to use them just to basically solve some problems. So what we're going to go through today is some just basic ideas of trig identities, some basic relationships of trig identities. When you're solving trig identities, you have to have equals. We're going to use the idea of a substitution principle. And when we use the substitution principle, we replace something with what it's equal to. Okay, so when we're dealing with trig identities, we look for a lot of things that are equal, so we can use this idea of a substitution principle, so I can replace something with something that it's equal to. And that's how you prove trig identities. And once again, you won't have to prove them, but we're going to still go through some basic ideas, because these ideas are prevalent in the basic foundation of all trigonometric ideas that we will go through today. The first sets of equalities we have are called the reciprocal functions, and we've touched on these already. If I have the cosecant, this can also be written as 1 over the sine of x. Remember, they are reciprocal functions of each other. So if I have the cosecant of x, this is equal to 1 over the sine of x. And if I have sine of x, this is equal to 1 over the cosecant of x. Once again, they are reciprocal functions. So we can write them as reciprocal functions. And if I'm going too fast, once again, how you slow me down is just hit the pause button. Hit the pause button. I'll shut up, and I'll make sure I won't keep talking while the pause is on. And then you can hit play again once you catch up. So these are reciprocal functions, so we can rewrite them as reciprocal functions. And likewise, secant and cosine are reciprocal functions. Okay, secant can be written as 1 over cosine of x, or cosine of x could be equal 1 over the secant of x. Once again, what I always tell students, C goes with S goes with C, S goes with C, C goes with S. Okay, C's, the cos don't go together. So cosecant doesn't go with cosine. Secant and cosine, cosecant and sine, they go together. And likewise, when we have the cotangent, this is a reciprocal of tangent. So we can rewrite cotangent as 1 over the tangent of x, and tangent of x is equal to 1 over the cotangent of x. And once again, if you need to pause, that's okay. I won't find offense to you pausing. I'm just trying to, I'll go through the material here so I don't have to download as much to a YouTube video then at that point. But you can always pause and catch up. The tangent, what we learned when we were graphing our secants, cosecants, tangents, and cotangents, we also learned two different ideas. The tangent can be written as sine of x over cosine of x, and the cotangent can be written as cosine over sine. So once again, reciprocal ideas, but tangent of x, if I had a tangent of 50 degrees, that would equal the sine of 50 over the cosine of 50. Okay, there, once again, it's just a different way of rewriting it. Now comes the very, very basic trig identity that leads into a lot of different things. If I take the sine of x and the cosine of x and I square them, and now these are the same angles, they will always equal the value of 1. Sine squared plus cosine squared is equal to 1. This is a very important idea. And once again, we're looking at, this means the sine of x. I take the sine of x and I square that. I take the cosine of x and I square that. I will get the value of 1. Now these have to be the same angles. Now we will go through some derivation of this. And to use the derivation of this, what we're going to use is this right triangle here. Here's my angle theta. Here's my angle theta. And if I take a look at my angle theta, and I look at the sine of this x or this theta, the sine is defined to us as opposite over hypotenuse. So we have y over r squared. The cosine of this angle is defined to us as adjacent over hypotenuse. So we have plus x over r squared. Now if I use some algebraic skills, I distribute my squared term over both of these terms. We have y squared over r squared plus x squared over r squared. Well, what we have here is we have two fractions that we're asked to add together. Okay, we're asked to add these together. Well, to add these two fractions together, we need to have a common denominator. Well, our common denominator is that value of r squared. So this is equal to y squared plus x squared over r squared. Now, if we take a look at our triangle here, and we pull out our good old buddy Pythagoras. We'll make him a little bit smaller. There we go. We'll pull out our good old buddy Pythagoras. Our good old buddy Pythagoras here says I have x squared plus y squared. This is going to equal r squared. Leg squared plus leg squared equals the hypotenuse squared. So using our substitution principle, this x squared plus y squared is equal to r squared. So wherever I see x squared plus y squared, I can substitute that in. So we're left with r squared over r squared. When I take something and divide by itself, I get a value of 1. So what we use is a general form idea here. A general form idea, and we prove that if I take the sine squared plus cosine squared for any right triangle, again, this is a right triangle, if these angles are the same, I'm going to get a value of 1. That will be true for anything. I think one of your problems I'm going to ask you to do, sort of ask you to do that. So if you would take the sine, and it does not matter what angle, make sure you're in the degree mode, that should not even matter, 50 squared plus the cosine of 50, and square that, and add them together, what you should result is a value of 1. And you'd have to type it in this way. I think your calculator will put parentheses here, they'll put parentheses there, so you need to make sure you do your parentheses. But if you would take the sine squared plus the cosine squared of 50 degrees, you get a value of 1. Let's see if that's true. Pull out my calculator here. make sure I'm in my correct mode and I'm in radians. Let's go down to degrees. Let's quit. So let's take the sine. Oh, I screwed up. Parenthesis, sine of 50 squared plus parenthesis cosine of 50 squared. And if I would add these together, voila, I get a value of 1. And it does not matter which trig value or angle value you utilize there. Now from this we have some offshoots. We have sine squared plus cosine squared is equal to 1. And this will be utilized when you get into upper level mathematics and you get into the calculus. But if I subtract cosine squared from both sides, another way of writing this would be sine squared of x is equal to 1 minus cosine squared of x, which, if you use some algebraic skills, if I had 1 minus y squared and I ask you to factor that, this would factor into 1 minus y and 1 plus y. This is a difference of perfect squares. This is what we have here. So this would factor down into 1 minus cosine of x and 1 plus cosine of x. Likewise, up here, if I would subtract the sine squared of x instead of the cosine squared, we'd be left with cosine squared of x is equal to 1 minus sine squared of x. And we could do the exact same type of factoring. 1 minus sine of x and 1 plus sine of x. Once again, these would be very useful if we were going to be proving trig identities. Since we're not, this is just some derivations of what we do with trig identities. If we take this principle that we have right here, we're going to go up here. Sine squared plus cosine squared is equal to 1. And we're going to derive some different types of formulas off of this, which are, once again, very basic trig identities that you will eventually use when you get to the upper level calculus world. If I take, and you won't be responsible for proving them, but it's sort of nice to go through some proofs of trig identities, because these are things of just general forms. If I would divide through everything by cosine squared, we have sine squared over cosine squared. Well, if we look back, what sine over cosine is equal to tangent. So if I have sine squared over cosine squared, that's going to equal what? That's exactly correct, tangent squared. If I have something and dividing by itself, I have plus 1, and 1 over cosine squared will equal secant squared of x. So this gives us another relationship. Secant squared of x is equal to tangent squared of x plus 1. Up here, if I subtract 1, we will be left with tangent squared is equal to secant squared of x minus 1. Once again, these are fundamental trig relationships that, as you go through mathematics, that we will continue to utilize, because you'll eventually get to having to work upper level mathematics with trig functions. And these upper level mathematics lead to these ideas that we talked about. Going back up, the sine squared plus cosine squared is equal to 1. If we would divide through now by sine squared, dividing everything through by sine squared, we have something divided by itself that gives me 1. Cosine squared over sine squared will give us now cotangent squared of x. 1 over sine squared will give us the cosecant squared of x. So this gives us another relationship between trig functions, where I have cosecant squared of x is equal to 1 plus cotangent squared of x. And like I did up top, if we subtract 1, we would have cotangent squared of x is equal to cosecant squared of x minus 1. Now these are all fundamental basic ideas with respect to trig identities. Once again, these all would be utilized to prove the trig identities, but since we're not going to go through and prove them, what we will do is I will ask you some questions about these things here on the little, I don't know if you want to call it an exit ticket, evaluation ticket, over the notes that we have today. Now, the rest of the notes that we have here, are proving trig identities. You don't have to worry about that because I will not ask you to prove any trig identities. So what I have here is some basic fundamental ideas. When you're proving trig identities, once again, the substitution principle is the main idea. That is the main idea that we will be utilizing, which is replacing a quantity with its equal. You're replacing a quantity with what it is equal to. And that is how we prove trig identities. So go ahead and now you can finish the little exit ticket, evaluation ticket, over basic trig identities. Tomorrow we'll come in, we'll get some more math problems. We'll deal with angle additions a little bit. We'll have double angles also that we'll be dealing with, and we'll solve a few of them. I'll ask you to do a problem or two like that, and that will be about all we will do with them. We'll keep it as basic as possible. Other than that, stay safe, okay? Keep your social distancing, talk to people, FaceTime some people. If I can figure out Google Classroom, I will figure out Google Classroom. I don't have a camera with a computer, so I don't know how to do it then. I need to continue to work on that, try to get better at it. But keep safe. If you have questions about anything, feel free to comment me. I will answer your questions through the comments to help you out as best as possible. Once again, stay safe, keep your social distancing. Adios. See you tomorrow.